Welcome back to the class. So in this class, we'll be looking at some examples in order to make the concept of convexity and concavity of functions to be clear. So, we have this example. Example 1 says check if the function y equals minus 2x raised by 3 plus 4x squared plus 9x minus 15 is convex, concave, or a point of inflection at x equals to 3. So don't forget the steps we highlighted in our previous class. So to solve this, so let's start with steps. There are 3 steps involved. So step 1, say find the first order derivative. Order derivative of the function. In other words, we have the function as y equals minus 2x raised to the power 3 plus 4x squared plus 9x minus 15. The first order derivative is y prime, that is the y dx, equals, so when we differentiate this one, we have minus 6x. Okay, if we differentiate this one too, so we have plus, this one we got 8x, then we have plus 9. Okay, so this becomes 0 because it's a constant. Okay, now step 2 says is to find the second order derivative. Sorry, this is derivative of the function. So the second order derivative of the function, that's y prime prime, means that we need to differentiate this first order derivative. So this, we differentiate this function. Okay, sorry, this one is 6 minus 6x squared. Okay, plus 8x plus 9. Okay, now we differentiate this 6x squared, it's going to give us minus 12x. Then plus, we differentiate this one, it gives us 8. This is a constant, it becomes 0. Okay, now the last step, that is step 3, says we should evaluate y prime prime, that is the second order derivative at x equals 3, because that's what we are given. So in other words, we are going to have y prime prime evaluated as 3, that will be equals to, whenever we see x, we put 3, so we have minus 12. Then we have 3 plus 8. Okay, so 12 times minus 12 times 3, that was minus 36. Then plus 8. Okay, so this, if you have this minus 36 plus 8, that gives us what? That gives minus 28. Am I right? That gives us minus 28. Okay, this minus 28, is it positive or negative? If it's negative, you can see it's less than 0. So meaning that the function is what? Is concave. So meaning that at point x equals to 3, this function is concave. You can see it's very simple. So let's take a look at another example. So example, let me call that example 2. So we have to test the same thing. So I'm not going to repeat all this. So I'll just check if the function is y equal, that is, we have to check if the function is, we could use f of x equal minus 7x raised to the power 3 plus 1, 2 plus 12. So we have to evaluate this function at x, also x equals to 2. Sorry, at x equals to 2. Okay, we want to check whether it is convex, concave, or point of inflection at x equals to 2. So we follow the step 1, we have to find the first order derivative. Okay, So the first order derivative, we have to find out, that is find the first order derivative. So we have to find, that is f prime of x, this first order derivatives. So if you have to find out, we have f prime of x, you differentiate this one, so we are going to have, if you differentiate this one, we have minus 21x squared, then plus 0, because it is a constant, it goes away. So step 2, so we have to find the second order derivative, that is f prime prime. Okay, so f prime prime, we have to find out, that is meaning that we have to differentiate this once again. If we differentiate this once again, that gives us minus 42x. So and the last step, step 3, we have to evaluate this function, that's f prime prime of x at x equal to 2. So in other words, we have to find f prime prime 2. Wherever we see 2, wherever you see x, we put 2, equal to minus 42, then x 2. So this is equal, this is equals to 84 minus 84. So it's still concave because it is less than 0. So the function is concave. Okay. Now let me, for knowledge sake, let me just do something now. So this is the question anyway. Assuming this does not have minus, okay, and if you have to differentiate this, the first derivative, this negative will not be there, and this will not be there. And if you have to evaluate it, you can see we are going to get a positive answer here. Okay, and so this is going to be greater than 0. So in that wise, the function, if it is positive, function is going to be what? Convex. Okay, because this is greater than 0. Hope that is clear. Okay, now let's also take a look at another one, that is some. Now let's also take a look at another example. Let's take a look at another example, and I'm just going to manipulate this. So let's say this is example 3. Okay, let's say we have this. Let's say we have y equal to x raised to power 3. Then we have minus 6x squared. So we want to test whether this is concave, convex, or a point of inflection at x equals to 2, not 3. So we follow the 3 steps. So step 1. So we have to find the first order derivative, that is y prime. So we have to find the y prime of this. We have to differentiate it with respect to x. So we are going to have 3x squared minus 12x. Okay. So step 2. So what do we have in step 2? So we have to find the second order derivatives, that is y prime prime, y prime prime. So we differentiate this once again. That will be 6x minus 12. Okay. And the next step is to evaluate this, that is at 2. So we have to find y prime prime evaluated at 2. Sorry. So this is equivalent to find y prime prime at x equals to 2. So we are going to evaluate that. So y prime prime 2 is equals to, whenever we see x, we put 2, that will be 6, 2 minus 12. So this is equivalent to 12 minus 12, and this is equal to 0. So in this wise, the test is inconclusive. So we say inconclusive. So we need to carry out further investigation to determine whether it is convex, concave, or a point of inflection. But one thing is that there is possibility of point of inflection here. Okay, because it's equal to 0. Okay, if it is negative, we'll have said it is concave. If it is positive, we will have said it is convex, but it is inconclusive, so there is possibility of point of inflection. That does not mean that it's going to be a point of inflection, but there is a possibility. That is what it implies. So now, to do that, what are you going to do? We need to continue to differentiate. Okay, we find the higher order derivatives of this function. So this is where we stop with our derivatives. So in other words, so we go further to the next step. So this step 3, so step 4. This one equals step 4 until we get a non-zero value. So when we evaluate, so we have to find y prime prime prime. Okay, y prime prime prime. So we have to differentiate this once again. If we differentiate this one again, that is going to give us 6. Okay, so 6. So the next thing is to evaluate at. So let me do it here. So the next step, that's step 5. We evaluate y prime 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 at x equals to 2. Okay, this. So we have y prime 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 as 2 is equals to 6, which is what? Which is greater than 0, and also what? And also even number. Okay, and also even number. So why do we do this? Don't forget 6 is the same as 6 raised to power 6 equal to 6x raised to power 0. Okay, so if you plug in 6 to 2 raised by 0, this is 1, so we have 6 times 1, so which is 6. Okay, so that is why when your function only has a constant and you evaluate at a particular point, your answer is going to be equals to that constant. Okay, that is what we did here. So this is positive and also even number. Okay, that's an indication that this function is convex. Okay, the function is what? Is convex. Okay, so to summarize it once again, if the second order derivative evaluated at a point is positive, the function is said to be convex at that particular point. But if the second order derivative is evaluated at a point is negative, that is, it is less than 0, we say the function is, if it's less than 0, we say the function is concave. Okay, if it's greater than 0, we say the function is convex, like this. But if it's less than 0, we say the function is what? Is concave. But if the second order derivatives evaluated at a point is equal to 0, the test is inconclusive. We need to carry out further investigation. Okay, until we continue to find the higher order derivatives until we get a non-evaluated at that particular point, until we get a non-zero value. Okay, if the value we got is odd number, whether positive or negative, so we say at that point, okay, so the function is at a point of inflection. But if it is even number, negative even number, we say the function is concave. If it is positive even number, we say the function is convex. Bye. See you in the next class.